Hoffman from Particle. I recently watched the movie Chucky and thought it looked like fun. So today we're going to use a particle photon and if this then that to make a haunted doll. Our doll will probably not come to life and murder anyone, but it will make the lights blink and cause monsters to jump out and scare you. Well, probably not you. You're not scared. You're not scared easily. But other people. All right. The goal of this project is to make a haunted doll that scares people by making lamps flicker, changing the color of LED strip lights, and causing a monster to poke its head out from a hiding place. To make this happen, we're going to build a circuit that uses a PIR sensor to detect motion in a room. When the sensor detects someone moving around, it will use a service called If This Then That to control different smart lights. It will also trigger movement from a mask that we've attached to a servo motor. This project is pretty straightforward on the programming side, but the construction takes a bit of time because it involves painting and some optional soldering. I suggest setting aside an afternoon or evening for it. A dark and stormy night would also work. Before starting, make sure you have your photon set up. If you don't have your board set up, go to setup.particle.io and follow the steps there before continuing with this video. You will need a breadboard, a PIR sensor, a servo motor, Govee or Hue compatible lights, 9 male-to-male wires, 3 male-to-female wires, a power supply, a particle photon, a doll with a removable head, black and white acrylic paints, and optionally black or navy fabric dye. All right, let's get building. Attach your photon to the breadboard. Wire from the VIN pin on the positive side of your breadboard and the GND or ground pin to the negative side. Once you have your board set up, attach a PIR sensor. PIR, or passive infrared sensors, can detect the movement of things that emit heat, like warm bodies. This is good for our purposes because it can sense a child passing by, but won't be triggered if, a ghost zooms in front of it. The PIR sensor has 3 pins: ground, out, and 5-volt. Connect the ground pin to the negative side of your breadboard, connect out to D1, and connect the 5-volt to the positive side of your breadboard. Now the PIR sensor will be able to transmit signals to the D1 pin. Now it's time to program our sensor. I like to use Particle's VS Code extension Workbench for programming. If you don't already have it, you can download it at particle.io/workbench. Once you have Workbench set up, create a new project named Haunted Doll. Go into the source folder and open haunteddoll.ino. At the top of your program, declare the sensor as motion sensor and assign it pin D1. Next, create a variable called sensor state and set it to low since we want to start it off with no motion detected. Make another variable called sensor value and set it to 0. Lastly, create a variable called LED and declare it at pin D7. This is the photon's onboard light. In the setup loop, tell our code that the sensor is an input by writing pin mode motion sensor input. Then declare LED as output so we can later use it to test if our code is working as expected. Inside our loop function, set the value of sensor to be equal to the read of sensor with sensor value equals digital read motion sensor. Then digital write the LED to low so it starts off with the light off. Now test to make sure the sensor is working. Inside the if statement, digital write LED high, then delay for 2000 milliseconds, then digital write LED low. Inside the else statement, digital write LED low. Write another if statement inside the first to check to see if the sensor state matches the sensor value. If it doesn't, it will be updated here. Then do the same within the else statement. Compile and flash your code. Wave your hand in front of the sensor. If it senses movement, the blue light on your photon should turn on for 2 seconds. This only works if you have a warm body, so if it doesn't work, you may be a vampire. Once you've confirmed that the sensor is working, call the Particle Publish function. Particle Publish is a cloud function that allows you to push an event to the Particle Cloud. This means any hook or application that's registered to listen to the event will be notified when it is called. Inside the if statement, call the particle publish function 3 times. Our publish functions take 2 strings. The first one is event name, and the second one is event contents. Our first instance of particle publish will contain the strings hue and blink. This will eventually make the lamps with our hue lights blink. Our second instance will contain LED and red. This will eventually cue our LED strips to change to red, the most sinister of all the LED colors. After this publish event, have the program keep the lights on red for 3 seconds with delay 3000, then call particle publish for the last time and give it the strings LED and purple. We'll be using this to change the LED lights back to purple. Next, we're going to connect our particle device to a service called If This Then That, which will allow us to control smart devices through the cloud without having to wire them to our photon. Go to IFTTT.com and create an account. Once you're logged in, click on the Create button in the top right corner. Select the Add button next to the If This option. Search services for Particle. You'll have to log into your Particle account and grant permissions. Select the new event published trigger. Type in hue for the event name and blink for the contents. Then make sure the device name that the trigger is watching is the correct device. Now press the Create Trigger button. You have set up the if portion. Next, click the Add button next to the phrase, then that. Search the services for the smart light provider that you're using. I used Zigbee lights connected to my Hue Hub for lamp lights and Govee LED strip lights for the LEDs around it and in my doll. Select the action for blink, because flickering lights are always really creepy in horror movies. Then click on the name that you've given your lights and press Create Action. Review your applet and press Finish to set it up. Test it out to make sure it's working. There may be a bit of lag for new applets, but you can trigger the app to run by pressing the Check Now button to speed things up. Repeat this process with your other publish function and sets of lights, selecting Govee instead of Hue. Check out the other services and see what's available. If there's anything that interests you, create an applet and have it be triggered by motion sensors. You could even publish an applet that makes If This Then That send you an email whenever motion is detected. What's scarier than more emails? Personally, that is my nightmare.
A haunted doll that makes the lights change is scary, but not scary enough. You know what's really scary? Monsters are scary! I don't know any real monsters, so we're going to use a servo motor and a monster mask to make a monster appear and retreat. There are different types of servo motors. I'm using a simple, cheap servo that has a rotational range of 180 degrees. Servos are highly precise, and we can send a servo to any angle between 1 and 180 degrees. Much like our PIR sensor, the servo has 3 wires, the ground, the 5-volt, and the digital. Unlike the PIR sensor, the servo has sockets at the end of the wires instead of pins. Connect the double pin or male-to-male wires to them. Use the longest ones you have. You can even use a giant spool of wire so the jump scare can happen really far away from the doll. Connect the darkest wire to the ground in the negative section of our breadboard. Connect the middle wire to the positive section. Connect the final wire to D0. Now that we've wired it, it's time to program the motor. Declare your motor at the top of the program. I named mine Mask Motor. Servo motors operate between the degrees of 0 and 180. Inside our sensor checking if statement, use maskmotor.write and then the degree number to set the motor to go to 180 degrees. Then delay 2000 to delay for 2 seconds. Then maskmotor.write again, but this time write it to 0. This is very similar to sweeping a servo, but sweeping is a continuous motion, and I think it's scarier to have the monster leap out, pause, and then retreat. All right, compile and flash your code. Now that everything is programmed, let's turn this from a standard circuit into a haunted doll. Dolls are creepy by nature. We're going to make this one even creepier. First, derobe the doll. Paint all of the vinyl or plastic portions with a layer of black acrylic paint, making sure to get all of the crevices, especially the hands. It's really easy to miss the hands. While the paint is drying, begin distressing the doll clothes. Cut them up a bit, and if you want to dye them, use your fabric dye to start the dyeing process now. Once the black paint is dry, paint a coat of white acrylic paint over the doll, giving it a grayish, undead complexion. Now, behead the doll and stab out its eyes. If this doll ever does come to life, it will haunt you, and then it will haunt me for telling you to do that in the first place. I accept this fate. Shove part of your LED strip into the doll's head so its eyes will glow red and purple when it's triggered. Put your Halloween mask around the block of styrofoam. Attach chopsticks to your servo motor and shove them through the bottom of the foam. Put the styrofoam mask across from the doll and hide it behind a curtain, box, or other large object. The one thing creepier than a doll is a doll with an evil robot inside of it. There are many options for attaching the circuit.
I just put mine on the doll's lap and then covered everything but the sensor with an old pillowcase. It's not the most elegant solution, but it worked.
Now, when you walk by, the haunting begins. If you have any questions about this or want to show off your own builds, go to community.particle.io and make a post. You can also suggest things for us to build next. Happy hacking!